Okay, in this video, we are going to discuss segments. We're going to explore them in depth. So let's start by talking about congruent segments. Congruency is a very important concept in this course, so we're going to go ahead and start that introduction today. Congruent segments are segments that share the same length. Okay, I have segments AB and XY drawn here. AB is 3.7 units long, and XY is 3.7 units long. So I can say that the measure of AB equals the measure of XY. This little in here means measure. And we're going to want to make sure that we take note of that in our sidebar. All right, I also want to make note of my key terms. So I have congruent segments, and that's now noted. We are going to discuss what happens if I draw a third point along a segment and if that breaks our point up into two chunks. We're going to talk about the segment addition postulate. But before we do that, we're going to talk about what a postulate is. And a postulate is an argument that does not need proof. So I put that there on the side. A postulate is an argument that's accepted without proof. And one argument we accept without a formal proof is that if we have a segment, and it's segment AB, and there's a point C that lies between those, then we can take the two sections. So I can take the section AC, and I can add it to CB, and that gives me the total segment. All right, so let's look at that in action. Let's assign some theoretical numbers. Let's pretend that this section right here is 7, and this section right here is 5. All right, this is saying that if I could take AC and add CB, it's going to give me the total AB. Well, I'm going to go ahead and plug numbers in for those. All right, I've drawn this symbol here to show that my equation is progressing forward to a next step. That's what that symbol means. All right, and I'm going to plug in my numbers. So I have 7 for AC and 5 for CB. And I know that when I add those together, it's going to give me the total AB. I'm going to take 7 plus 5, and that gives me 12. And so now I see that the total segment AB is 12. We can also use the converse of this postulate to find a missing piece. So let's look at that now. Okay, here I have a segment AB. And I see that the total segment is 15, and my portion between C and B is 5. So again, I can write out that AC plus CB is going to give me the total segment AC. And by AC, I mean AB. And I can go ahead and plug my values in. So I'm going to draw that my equation's moving on. I don't know what AC is. There's a little invisible question mark here. But I know that CB is 5. And then I know that my total segment AB is 15. So I know I need some number plus 5 to equal 15. I can also use inverse operations if I prefer to solve that way. Either way, I'm going to get that AC is equal to 10. So that's two ways we can use the segment addition postulate. All right, that concludes these notes.